Hi, I'm Alex. This is Oh, That's Why, a podcast about JavaScript, finally making sense. Let's dig in. There is a short piece of JavaScript that gets passed around as a joke. A kind of gotcha shared whenever someone wants to make the point that the language is broken. Quote 5 plus 3. You expect 8. You get quote 53. A string. Quote 5 minus 3. You expect a different string or maybe an error. You get 2. A number. Same inputs, different operators. A string in one case, a number in the other. And JavaScript just accepted both without complaint. This gets shared as evidence that the language is unpredictable, irrational, broken. It is none of those things. The behavior is completely consistent. It follows a specific set of rules that are documented, deterministic, and once you understand them, entirely predictable. The problem is that almost nobody learns the rules. They learn the results. They memorize gotchas. And because they never understood the underlying system, every new variation feels like a new surprise. So today we learn the system, and after this episode, none of it will surprise you anymore. Imagine a translator. Not one you hired, not one you asked for, one who is just always there, working silently in the background. Whenever you hand them two things and ask them to work with both, they look at what you gave them. If the two things speak different languages, if they are different types, the translator converts one of them before doing the work. You never asked for translation. You never knew it happened. You just got a result. This is type coercion. JavaScript acting as the translator, silently converting one type to another when an operation requires it. The critical question is, which type gets converted and to what? That depends on the operation. Different operations have different expectations. The addition operator works with numbers, but it also works with strings because strings can be concatenated. When you mix a number and a string in an addition, JavaScript has to decide which way to go. The rule: when adding, if either value is a string, treat both as strings. Concatenate. So quote 5 plus 3 becomes quote 53. The number 3 got quietly translated to the string quote 3, and the two strings were joined. But the minus operator is different. Subtraction only works with numbers. It has no string behavior. When you hand it a string, the translator always converts to numbers. Quote 5 minus 3, both become numbers. 5 minus 3, 2. The translator has different rules for different situations, and the rules are consistent, always. Let's go through the actual rules. JavaScript has an internal set of conversion operations. 3 of them are used constantly: ToString, ToNumber, and ToPrimitive. ToString converts a value to a string. Most things convert intuitively. The number 42 becomes the string 42, true becomes true, null becomes null, undefined becomes undefined. Arrays join their elements with commas. An empty array becomes an empty string. Objects become the string bracket object object bracket unless they have a custom toString method. ToNumber converts a value to a number. Empty string becomes 0. A string of digits becomes that number. True becomes 1. False becomes 0. Null becomes 0. Undefined becomes NaN, not a number, a special value that means the conversion failed. An empty array becomes 0. An object becomes NaN. ToPrimitive is what JavaScript calls when it needs to convert an object to a primitive. Objects have a value of method. If value of returns something that is not an object, that value is used. If not, JavaScript tries toString. The order depends on what kind of operation is happening. Now, the plus operator. If either operand is a string, plus is string concatenation. Both sides convert to strings and join. If neither is a string, plus is arithmetic addition. Both sides convert to numbers and add. Every other arithmetic operator, minus, multiply, divide, modulo, only works with numbers. No string mode. Both operands always go through ToNumber. Now, the famous one, empty brackets plus empty object. An empty array converts to a primitive. Value of returns the array itself, not a primitive. So JavaScript calls ToString. An empty array's ToString returns an empty string. The brackets become empty string. An empty object converts to a primitive. Value of returns the object itself. JavaScript calls ToString. An empty object's ToString returns bracket object object bracket. Empty string plus bracket object object bracket. String concatenation. Result: bracket object object bracket. That is not chaos. That is 6 individual conversion rules applied in sequence, producing a completely deterministic result. The rules are consistent. They just need to be learned. The trap that bites most developers is implicit coercion in conditions. And it is so common I have to call it out specifically. When you write an if statement, JavaScript converts the condition to a Boolean. Values that convert to false are called falsy. 0, empty string, null, undefined, nan, and false itself. Everything else is truthy. The problem is that some falsy values are legitimate data. 0 is a valid count. An empty string is a valid response from a form field. If you write an if check that uses a number or string directly as a condition, without explicitly comparing it, you might accidentally exclude valid data. Your code works for most inputs and silently fails on 0. One of the quieter bugs out there. The fix: compare explicitly. Do not rely on implicit Boolean coercion for anything that could legitimately be 0 or an empty string. Second trap: using plus with data you have not verified. Something that comes from user input or an API response. It arrives as a string. You try to add it to a number. You get concatenation. 10 plus 5 is 105, not 15. The fix: convert explicitly first. Number, parse int, parse float, pick your weapon. The third is nan. Whenever a ToNumber conversion fails, when something truly cannot be converted, JavaScript produces nan. And nan has one property that trips everyone. Nan is not equal to nan. You cannot check whether something is nan by comparing it to nan. The comparison always returns false. The correct way to check is number.isNan, not the older isNan function, which does implicit coercion first and can give false positives. Coercion has rules. Once you know them, nothing JavaScript produces from mixed types will ever surprise you again. It is not broken. It is not random. It is a translator with a defined rulebook, doing its job whether you asked it to or not. The companion article on Medium walks through ToString, ToNumber, and ToPrimitive, with examples of every conversion that matters in practice. Link is in the show notes. Next week, loose versus strict equality, the double equals and the triple equals. Most developers are told to always use triple equals without ever understanding why. After today, we can actually explain the difference, because the double equals is coercion in disguise. I'm Alex Vega. This is Oh, That's Why. The next time someone shares that JavaScript joke, you will know exactly why. And that changes everything. See you next week.